So I quickly wanted to talk about PLV8ify. It's a CLI that can turn TypeScript functions into Postgres functions. Uh, yeah, so why would I build something like this? Well, it's a side project, so that's reason enough in itself. But generally, I was working on the side project which needed me to detect sprints from a game of football. So when you like accelerate very quickly for a very short period of time and once, and normally you would deal with geo JSON kind of stuff with Postgres, but the provider I was using back then for Postgres did not support Postgres and did not support custom extensions. So I was using a library called turf.js, and turf.js is a JavaScript-based implementation of geo data functions essentially, and then everything was happening in JS land. And then I was also tinkering with the algorithm a lot. And one of the problems I faced was that I had to run a cron job to update all the data. If I change the algorithm, then I have to do it again. And I thought, wouldn't it be nice if I could do all of this in Postgres? So if I could somehow port turf.js to Postgres. And I was aware of this extension called PLV8, which allows you to run JavaScript within Postgres. And then I looked on different tools that allow you to do that, and none of them had a very good developer experience. And that was how I came about this idea. But mostly this was going to be a side project, like always. So how it fundamentally works is that it bundles JavaScript into uh, a Postgres function. So essentially, it uses ESBuild as a bundler and converts this function into this, and then it wraps it inside the syntax of writing a Postgres function that uses PLV8 as its language. So fundamentally, that's how hello world looks like in PLV8ify. You can do select PLV8ify hello. If you've written a function and invoked the CLI, it will produce something like this, and this you have to like copy paste into Postgres. And this was fun, but then I had an interesting idea. What if I could run the same function on React.js? Because React.js is also JavaScript. And then React also works kinda, and this was an amazing feeling. So I could write a React function, and then I could render it to static markup, and then feed it to PLV8ify, and I got out of it a 5,000 line function, but calling it from Postgres did actually work. The kind of part here is because if there is anything that accesses DOM, so all the React components that access document or something that Postgres's V8 will not have, it will of course fail. But we can totally use this for some subset of server-side rendering happening within the database completely. And now we have globally distributed Postgres databases coming along. So this could also act as an edge function doing SSR for React. Fun stuff. I don't think anyone is using that right now. So unlike me, whose use cases are kind of fun, it also has some real use cases. So I found this, like people started picking it up on GitHub, and then there was this guy, and I asked him, like, what do you use it for? And it's like, I use it to sign AWS requests. So if S3 object is, for example, private, and you want it to be open for downloading for a few seconds with a temporary URL, you can sign the request, and that API doesn't invoke any network call, and that can be done then using PLV8ify within Postgres. Then the next steps for this project for me look like better workflows. So right now I already have a TypeScript native workflow, and you can use your editor and get all of those things. But to deploy a function, for example, you have to copy paste it. And I would want PLV8ify deploy, for example, to deploy all the functions. There's also more interesting efforts happening in Postgres. So for example, Wasmer Postgres allows you to run WASM extensions within Postgres. And I would love to wrap that also with PLV8ify, or maybe write another extension that can allow you allow you to write different programming languages and invoke that within Postgres. And then, yeah. So a few days ago, I attended Postgres SQL Advanced training, and then I was like confident enough to attempt this. So this essentially does the same thing which I try to do here. So it's the whole algorithm, but inside of TypeScript, I'm writing that in a skill completely. And the general idea is that you use window functions and then you build a concatenated string, and then using string extraction, you can know if someone is printing or not. So in this case, for example, S means that particular data point of speed was more than the threshold of a sprint. And if you have like 10 of them together, for example, you can say that it's a sprint. So yeah, fun stuff. And that is all. Please let me know if you have any questions.